Hello viewers, this is your chemistry teacher with a new topic, that is carboxylic acid. You know, as we are doing the series of organic chemistry, we have done few topics of organic chemistry, and now we are going to study carboxylic acids. As you know, carboxylic acids are a homologous series of organic acids which have the carboxyl group, that is COOH functional group. COOH can be written as C double bond O, O and H. This is the displayed formula, that is, I am showing all the bonds, and this bond over here actually is the fourth bond of carbon, 1, 2, 3 and 4, which is to be bonded to other alkyl groups. And there are quite different varieties of compounds which can be formed, and you can attach over here. Mainly we add carbons over here. General formula CnH2n plus 1 COOH, where N is O, 1 and 2, etc. Naming of the formula of acids: value of N. As you can see, I have written 0, 1, 2 and so on. Name of acid: methanoic acid. Molecular formula HCOOH. Structural formula HC double bond O and OH. I will again revise. Meth means 1 carbon. Here we also have 1 carbon. Then we have ethanoic acid. Eth means 2. So we have 2 carbons, and this is the formula. Then propanoic acid, we have 3 carbons, and this is the formula. Then we have butanoic acid, and butanoic acid 4 carbons, 1, 2, 3, 4, and this is the formula. You can notice one thing, that the carboxyl group comes always on the edge. It never comes in the center. Now there is 1 carbon. This is how we form the formula of methanoic acid. Here N is going to be 0. There is 1 carbon atom already present in the formula. So methanoic is found by putting N is equal to 0. Now here I have written N is equal to 0. 2 multiplied by 0. 0 is the value of N plus 1. COOH, which is already present in the formula. So this comes out to be H, because here we cancel out C and H. 2 multiplied by 0 is 0. So 0 plus 1 is 1. So we have only one H. HCOOH. So this is how we find out the formula of methanoic acid. And in the same way, we can find out the formulas of other acids. Of the acids, they are liquid. Their boiling point increases as the molecular mass increases. Lower acids are soluble in water. Their solubility decreases as the molecular size increases. Common organic acids: lactic acid, it is present in the sour milk. Oxalic acid, spinach, rhubarb plant. Citric acid, limes, lemons, citrus fruits. Formic acid, insect bite and stinging nettle. Tartaric acid, grape juice. Now malic acetic acid in vinegar. Malic acid, apples and pears. Uses of organic acids: paints, drugs, plastics, insecticides and dyes. They are used in all these different compounds. Ethanoic acid, we are very much aware of ethanoic acid, that this is commonly known as vinegar, and vinegar is used as flavoring agent or preservative. Now we come to the properties of carboxylic acid, that is physical properties, as we have already studied. Now we come to the chemical properties. These are weak acids because they ionize only partially in aqueous solution. Partially means that is to some extent. Just giving you a rough example, that if there are 100 molecules of ethanoic acid or carboxylic acid, out of 100 we can say that 10 molecules will ionize in the ionic form and the rest will remain as the acid. So, and we have written a reversible sign over here, that is an equilibrium between the ions and the acid itself. There is a forward reaction and also the backward reaction. Ethanoic acid ionizes as acetate ion. This H is going to be removed and will form H positive aqueous. So when we say ionize, you already know that there is a covalent bond between O and H, and in a single covalent bond we have 2 electrons. So when it ionizes like this, H is going to leave its electron over here and will form H positive ion, and that extra electron will make it negatively charged. This is methanoic acid, methanoate ion and H positive. This H is being changed as H positive. You must be sure that when we are writing the acids, there are many hydrogens. So the hydrogen which is going to ionize as H positive is always the H of the OH group. Propanoic acid, so this is propanoate, H positive. This is butanoic acid, and this is butanoate and H positive aqueous. Now I have written again over here, this is the sign which shows reversible and forward reactions both. Now I come to the reactions. All other acids, carboxylic acids, produce H positive ion, due to which they show all the acidic properties. Now first reaction, reaction with reactive metals. As you know that I have already said that these acids are weak acids, so we need reactive metals to react with them, such as sodium, potassium and magnesium, to produce salt and hydrogen. Salts are known as OATE. We are going to write the name OATE after it, that is ethanoate. This is acetic acid, ethanoic acid, reacting with sodium. Sodium is going to remove this hydrogen from here and is going to take its place, and this forms sodium ethanoate plus hydrogen gas. So in order to balance the atoms, I have written 2, 2 and 2 over here. Then ethanoic acid plus magnesium, magnesium ethanoate plus hydrogen gas. Here this is butanoic acid. With sodium it forms sodium butanoate plus hydrogen gas. This is butanoic acid. Magnesium butanoic acid with magnesium forms magnesium butanoate hydrogen. You can see that this OATE8 is written against the name of the carboxylic acid. Methanoic acid, aluminium. This is aluminium methanoate plus hydrogen gas. Now you must have noticed one thing, that there are sometime I am writing single CH3COO. Here I have written 2 and then 2 and then 3. It is because in order to balance the valencies of the metals. Sodium has positive 1 valency, so this forms C3H7COH minus 1. Therefore there is going to be 1 sodium ion and 1 butanoate ion. Here magnesium has 2 positive. So in order to measure balance 2 positive, we need 2 of the butanoate ions. For aluminium, aluminium has 3 positive. So in order to balance 3 positive, we need 1, 2, 3 negative methanoate ions. Here 2 acetate ions or ethanoic ions. So this is 2 positive and this balances with magnesium. Now number 2, reaction with carbonates. As most of the acids, rather all acids, when they react with carbonates, they form salts, carbon dioxide and water. So carboxylic acids also, when react with carbonate, forms salt, carbon dioxide and water. Taking the example of ethanoic acid plus sodium carbonate, sodium ethanoate plus carbon dioxide plus water. This is our ethanoic acid, sodium carbonate. See, I have written aqueous under it. Ethanoic acid plus sodium carbonate, sodium ethanoate, carbon dioxide and water. This is the reaction equation I have written. I am also balancing it. Must remember to balance accurately. This is ethanoic acid with calcium carbonate. This forms calcium ethanoate, water plus carbon dioxide. This reaction is used to remove calcium carbonate scales from kettle and from any other thing where there are deposits of calcium carbonate scales, and changes to this one from kettle. And this I have written acetic acid is vinegar. Reaction with bases. Carboxylic acid reacts with base to give salt and water. This is the word equation. This is another word equation using ethanoic acid, sodium hydroxide, sodium ethanoate plus water. This I have written the equation. Now sodium is going to remove this hydrogen, displace, and is going to take its place, and then this H and this OH, this H and this OH is going to form water. The same over here, it's going to form sodium butanoate because there are 4 carbon atoms over here. I hope you can understand my lecture and these reactions. I am trying to explain these reactions as easily as possible. Now the fourth reaction is reaction with alcohol. Now this is a very important reaction. Carboxylic acid reacts with alcohol to produce esters or esters. The process is known as esterification. An ester is a colorless liquid that is insoluble in water. Its functional group is, this is showing the bond, carbon double bond O, and again this bond over here. When ethanoic acid is warmed with ethanol in the presence of few drops of concentrated sulfuric acid, which is used as a catalyst, water and an ester is formed. Ethanoic acid plus ethanol in the presence of few drops of concentrated sulfuric acid, ethyl ethanoate plus water is formed. Now ethyl group is derived from the alcohol and ethanoate is derived from the carboxylic acid. Now this is the reaction I have written. I will explain it under it. During the formation of ethyl ethanoate, the OH group from the ethanoic acid, this OH group from the ethanoic acid is replaced by this group of alcohol. Now this I have written ethanoic acid, 1 carbon CH3, C double bond O and OH, and this is ethanol. So hydrogen of ethanol and OH of the ethanoic acid is removed and it forms water over here. So this is the group. This group is from the carboxylic acid and this group is from the alcohol. So we are going to write down the name first of the alcohol from which is derived. It is derived. So the alcohol over here was ethanol and it changes to ethyl, and carboxylic acid was ethanoic acid, so it changes to ethanoate plus water. So this part, or we can write it down on the other way, that is we write the alcohol part first and the carboxylic acid part afterwards in order to make it in a correct order. That is, as we write the name of alcohol first, so we write alcohol first, ethyl, and then ethanoate. Both are correct. It can be written in this way or it can be written in this way, but the thing which you have to remember is that the name of the salt is going to be, the ester is going to be in a way that first you are going to write the name of the alcohol from which it is derived, and then we are going to write on the name of carboxylic acid. Now here I am giving you some examples of different esters formed because students, they sometimes face difficulty in writing down the names and forming the esters, because in your course there are 4 carbon in series, that is methanol, ethanol, propanol, butanol, and in the same way methanoic, ethanoic, propanoic and butanoic. So an ester can be made by choosing a carboxylic acid and alcohol and adding few drops of concentrated acids. So you can choose any one of it. The thing which you have to realize and notice is that now over here we have, I've written the name methyl methanoate. Now this methyl means it is going to come from the alcohol. Methanoate means it is going to come from the carboxylic acids. So methanoic acid is going to be written in this form, and methanol over here, 1 carbon over here, 1 carbon over here, H of alcohol, OH of the carboxylic group, and here the molecule is formed, the ester is formed. This is the part of the alcohol, that is methyl, and this is the part of the carboxylic acid, that is methanoate. Here. So this is methyl group and this is methanoate plus water, H from here and OH from here. Now methyl propanoate. So methyl again is methanol. You can see 1 carbon, CH3OH, and propanoate, now I have 1, 2, 3 carbons, OH group and C double bond O. H of the alcohol, OH of the acid is going to be removed from here and it is going to form water. And when H is removed, this much portion of the alcohol is left, CH3 and O. When OH is removed from the propanoic acid, this part of the propanoic acid remains. So the bond is actually formed between C double bond O and O. Initially, you remember that we have written the functional group of the ester was like this, C double bond O and O. Now this O actually comes from the alcohol and this forms from the carboxylic acid. So here this is actually the functional group. You can see the similarity. Now we have third one, that is ethyl propanoate. Now as I've written propanoate, this means it is from the propanoic acid. I have to write this is the propanoic acid. Ethyl means it is going to be ethanol. So this is ethanol. hydrogen, and OH from here is going to be removed and it is going to form water over here. This part is from the propanoic acid and this part is from the ethanol. So the name is going to be in the order what I have said is that we are going to write alcohol part first, that is ethyl propanoate. Ethyl propanoate. Now the fourth one, propyl butanoate. Butanoate, butanic acid, this is butanic acid, 1, 2, 3, 4. Propyl, this is propanol, 1, 2, 3. Again, H and OH forms water, and from when this OH is removed from here, it forms this group, and when H is removed from here, this forms this group, C3H7. Now as there was a little space over here, so I have written it like this. And again its name is going to be, first of all, the alcohol part, that is propyl, and then the acid part, that is butanoic. So it is going to be propyl butanoate. This is a diagrammatic representation. In laboratory you can prepare ester like this. In test tube you have ethanoic acid and ethanol. Then with a dropper add some few drops of concentrated sulfuric acid, which is going to act as a catalyst. Then put this test tube in a water bath. You must remember one thing, that whenever there is ethanol present, we do not heat it directly because ethanol is flammable. It can burn. So it is going to be in the water bath. Now once ester is formed, the reaction mixture is poured onto water. Now the water, now this one has sulfuric acid. This is going to be water plus sulfuric acid because it had water and sulfuric acid over here. One of the product of the esterification is water, you know. So water and sulfuric acid will dissolve in this water, whereas ester is actually insoluble in water, so it will form the upper layer. Just for you to remember, while writing down the names, we write first part of alcohol and then carboxylic acid part. Now we come to the uses of esters. Number 1, artificial food flavoring, as they have sweet and fruity smell. Now when you write down the use, you must know why it is used as food flavoring. So it is sweet and fruity smell. Methyl butanoate, smell like apple. Ethyl butanoate smell like pineapple. Then number 2, used as solvent for cosmetics, perfumes and glues. As with small molecular size, they are volatile liquids. So you know, when you use perfume, it actually evaporates and its aroma spreads around. Then it is used to make soaps. Animal fats, vegetable oils are naturally occurring esters. When these fats or oils are boiled with sodium hydroxide, soap is formed. Sodium salt of carboxylic acid actually is the salt which is formed. So I hope you have understood the carboxylic acids and esters and how to form an ester, its equations, and how to name an ester. I've tried to make as clear as it is possible. So if you like my channel and if you have understood it well, please subscribe my channel and also write comments, because your comments are very important for me, which are going to tell me what are the places where I have to improve and where you like my how you like my lectures. So thank you very much.